About 4.6 billion years ago, the solar system formed from a giant rotating cloud of gas and dust, called a solar nebula. Gravitational collapse. The nebula collapsed under its own gravity, possibly triggered by a nearby supernova explosion. Formation of the Sun. Most of the mass gathered at the center, forming a protostar, which eventually became the Sun. Planetary disk. The remaining material flattened into a rotating protoplanetary disk. Planet formation. Dust particles in the disk collided and stuck together, forming planetesimal small rocky bodies. These further combined to form protoplanets, which eventually became planets. Origin of the Earth. 1. Accretion phase. Approximately 4.5 billion years ago, Earth formed from the accumulation of planetesimals. In the inner part of the solar nebula, the inner region was hot, allowing only rocky materials to condense, which is why Earth is a terrestrial planet. 2. Differentiation. As the Earth grew, heat from collisions, compression, and radioactive decay caused it to melt. Heavier elements like iron and nickel sank to the center, forming the core, while lighter materials rose to form the mantle and crust. 3. Formation of the Moon. Giant impact hypothesis. A Mars-sized body that collided with the early Earth. The debris from the impact eventually coalesced to form the Moon. 4. Atmosphere and oceans. Volcanic outgassing released water vapor, carbon dioxide, and other gases, forming the early atmosphere. Water vapor condensed into oceans as the Earth cooled. If you'd like a visual diagram or timeline, I can create one for you.
The members of the solar system. Some with phase 1. The Sun. Type: G-type main sequence star, yellow dwarf. Mass: 99.86% of the solar system's total mass. Function: source of light, heat, and gravitational pull that holds the entire solar system together. Composition: mainly hydrogen, about 74%, and helium, about 24%. Ring planet 2. Planets. There are 8 major planets, divided into 2 types. A. Inner, terrestrial, planets. These are rocky, have solid surfaces, and are closer to the Sun. Planet features: Mercury closest to the Sun. No atmosphere. Extreme temperatures. Venus similar in size to Earth. Thick toxic atmosphere. Hottest planet. Earth supports life. Has liquid water. Only planet with known life. Mars red due to iron oxide. Has the largest volcano, Olympus Mons, and a thin atmosphere. B. Outer, gas/ice giants, planets. These are much larger and mostly made of gases or ices. Planet features: Jupiter largest planet. Has 79 plus moons. Famous for the Great Red Spot. Saturn known for its spectacular ring system. Has 80 plus moons. Uranus rotates on its side. Blue-green due to methane. Coldest atmosphere. Neptune deep blue color. Strong winds. Farthest known planet. Globe showing Europe, Africa. 3. Dwarf planets. Dwarf planets orbit the Sun but do not clear their orbit of other debris. Name location notes: Pluto Kuiper belt, once the 9th planet. Has 5 moon series asteroid. Beltonly dwarf planet in the inner solar system. Eris beyond Pluto, scattered disk, more massive than Pluto. Haumea Kuiper belt has an unusual elongated shape. Make Kuiper belt very cold and distant. 4. Asteroids. Small rocky bodies mostly in the asteroid belt between Mars and Jupiter. Irregular shapes, not round like planets. Largest, Ceres, also a dwarf planet. Vesta, Pallas. Believed to be leftover building blocks from the early solar system. Shooting star 6. Meteoroids, meteors, and meteorites. Term definition: meteoroid, a small piece of asteroid or comet floating in space. Meteor. Meteoroid that enters Earth's atmosphere and burns up. Shooting star, meteorite. A meteor that survives the atmosphere and hits the Earth's surface. Comet 7. Comets. Made of ice, rock, and dust. When near the Sun, they develop a glowing coma and tail that always points away from the Sun. Origin: Kuiper belt or Oort cloud. Famous comets: Halley's Comet, Hale-Bopp. Ice Cube 8. Kuiper belt and Oort cloud. A. Kuiper belt, a region beyond Neptune, 30 to 55 AU from the Sun. Contains icy bodies and dwarf planets like Pluto and Make. Similar to the asteroid belt, but much larger. B. Oort cloud, theoretical. Spherical shell far beyond the Kuiper belt. up to 100,000 Australian dollars. Believed to be the source of long-period comets. Not yet directly observed.
Earth's shape and motion.
Part 1. Earth's shape. 1. Actual shape of the Earth. Earth looks spherical from space, but it is not a perfect sphere. The Earth is best described as an oblate spheroid. Oblate spheroid. Flattened at the poles. Bulges at the equator. The equatorial diameter is about 12,756 kilometers, while the polar diameter is about 12,714 kilometers. This difference is about 42 kilometers, caused by Earth's rotation. 2. Why Earth is not a perfect sphere? Due to rotation, the centrifugal force pushes outward at the equator. This outward force causes the equator to bulge slightly and the poles to flatten. 3. Geoid. The most accurate description of Earth's shape is a geoid. A geoid is the shape that the surface of the oceans would take under the influence of Earth's gravity and rotation, ignoring tides and currents. It represents the true physical shape of Earth, showing slight gravitational irregularities. Part 2. Earth's motion. Earth shows several types of motion in space, but the two most important are rotation and revolution. 1. Rotation. Definition. Rotation is the spinning of the Earth on its own axis. Key facts. Earth rotates from west to east. One full rotation takes about 23 hours, 56 minutes, and for seconds approximately 24 hours. The axis of rotation is tilted at 23.5 relative to Earth's orbital. Plane ecliptic. Effects of rotation. Day and night. As Earth rotates, different parts face the sun and experience daylight, while the other side experiences night. Time zones. The division of Earth into 24 time zones is based on its rotation. Coriolis effect causes moving air and water to turn, affecting weather patterns. Bulging at the equator. Rotation creates centrifugal force that leads to equatorial bulge. Apparent motion of celestial bodies. The sun and stars appear to move from east to west. 2. Revolution. Revolution is the movement of Earth around the sun. Key facts. Earth follows an elliptical orbit around the sun. Takes 365.25 minus 1 year to complete one revolution. Earth travels at an average speed of 29.78 kilometers per second. Effects of revolution. Seasons. Caused due to Earth's tilted axis and its revolution. When the northern hemisphere is tilted toward the sun, it experiences summer, and the southern hemisphere has winter, and vice versa. Varying day lengths due to the tilt. Some places receive more or less sunlight throughout the year. Change in the position of the sun. The apparent height of the sun in the sky changes with seasons. Conclusion. The Earth is not a perfect sphere but an oblate spheroid, slightly flattened at the poles and bulging at the equator due to rotation. Earth's rotation causes day and night, while its revolution around the sun leads to the changing seasons. Other motions like precession, nutation, and Milankovitch cycles affect long-term climate and astronomical observations. Together, these motions shape our experience of time, weather, and the changing night sky. Thank you. Please like, share, write comments, and subscribe.